Let's start with a simple and fun introduction to our guest. Welcome to Chatbotcasts. Today, we have the pleasure of hosting a leading expert in quantum computing. Can you tell us a little bit about your background and what got you excited about quantum computing?
Thank you for having me on the show. I'm thrilled to be here and share my passion for quantum computing with your audience. To start, I've always been fascinated by how things work at a really small scale, like atoms and particles that are too tiny to see. Growing up, I was curious about the strange and amazing ways these tiny things behave, which is what quantum mechanics is all about. When I learned about quantum computing, it was like discovering a whole new world. Imagine a computer that can do many calculations at once, thanks to its ability to be in multiple states simultaneously. This is because quantum computers use something called qubits, which are different from the bits in your regular computer. In a regular computer, bits are either 0 or 1, but qubits can be both 0 and 1 at the same time. This means they can process a lot of information much faster than classical computers. For example, Google recently announced a breakthrough where their new quantum chip can solve a problem in just 5 minutes. That would take even the fastest supercomputers an incredibly long time. We're talking about 10 septillion years. This breakthrough is exciting because it shows how quantum computers can handle errors better as they get more powerful. Essentially, the more qubits you have, the more complex problems you can solve. Wow. And Google's new chip is a big step in making this technology more reliable and useful for real-world applications. So that's a bit about my background and why I'm so excited about quantum computing. It's a field that holds a lot of promise for solving problems that are currently beyond the reach of our classical computers.
Let's dive a bit deeper into what makes these qubits so special. Can you explain what superposition is in a way that a 5-year-old can understand? For example, how can a qubit be both 0 and 1 at the same time?
Okay, so imagine you have a special kind of coin that can be either heads or tails, but with a twist. In the world of quantum computing, this coin, or what we call a qubit, can be both heads and tails at the same time. This is what we mean by superposition. Think of it like a coin that's spinning in the air. While it's spinning, it's not really heads or tails yet. It's kind of both until it lands. For a qubit, it's like that spinning coin, but instead of landing on one side, it can stay in that spinning state, where it's both 0 and 1 simultaneously. This is really powerful because it allows the qubit to process a lot of information all at once. For example, if you had 2 coins, each could be either heads or tails, giving you 4 possible combinations. But with qubits, because they can be both heads and tails at the same time, you can explore all those combinations simultaneously, which makes quantum computers incredibly fast for certain types of problems. So, in simple terms, superposition is like a magic coin that can be 2 things at once. And that's what makes qubits so special and powerful in quantum computing.
That's a great way to explain superposition, Dr. Maria. Now let's talk about another interesting concept called entanglement. Can you explain entanglement in a simple way, like how 2 special coins can be connected in such a way that what happens to one coin instantly affects the other, even if they are really far apart?
Entanglement is another fascinating aspect of quantum computing that can be a bit tricky to grasp, but it's really cool once you understand it. Imagine you have 2 of those special coins that we talked about earlier, but this time they are connected in a very special way. When these coins are entangled, whatever happens to one coin instantly affects the other, no matter how far apart they are. It's as if they have a secret language that lets them communicate with each other in a way that's faster than anything we can see or measure. For example, if you flip one of the coins and it lands on heads, the other coin will instantly become tails, even if it's on the other side of the world. This happens without any physical connection between them. It's just the magic of quantum mechanics. In quantum computing, entangled qubits work together to solve problems. When you change the state of one qubit, it instantly changes the state of its entangled partner. This allows quantum computers to process complex information in a highly efficient way, making them incredibly powerful for certain types of calculations. So to sum it up, entanglement is like having 2 special coins that are connected in such a way that they can talk to each other instantly, no matter the distance. And this is what makes quantum computing so powerful and unique.
Let's talk about Google's recent breakthrough with the Willow chip. How does this new chip make quantum computing better, especially in terms of error correction and performance compared to previous chips like Sycamore?
Okay, so let's talk about Google's recent breakthrough with the Willow chip. This new chip is a significant step forward in making quantum computing more reliable and powerful. One of the main challenges in quantum computing is dealing with errors. Unlike classical computers, quantum computers are very sensitive to their environment, which can cause errors in their calculations. The Willow chip addresses this issue through something called quantum error correction. Imagine you're trying to send a message, but there's a lot of noise in the communication channel that can distort the message. Quantum error correction is like having a special way to encode the message so that even if some parts get distorted, the message can still be accurately decoded. Google's Willow chip uses a concept called logical qubits, which are essentially groups of physical qubits working together to correct errors. This means that even if some of the individual qubits make mistakes, the logical qubit can still provide the correct answer. This is a major milestone because it shows that we can build quantum computers that are not only powerful, but also reliable. Compared to the previous Sycamore chip, the Willow chip is much more robust. The Sycamore chip had 53 qubits and was already incredibly powerful, but it had limitations in terms of error correction. The new Willow chip, with its advanced error correction capabilities, can solve problems much more accurately and efficiently. So, in simple terms, the Willow chip makes quantum computing better by ensuring that the calculations are more accurate and reliable, even when dealing with complex and sensitive quantum systems. This breakthrough brings us closer to using quantum computers for real-world applications, such as drug discovery, climate modeling, and more.
That's really exciting to hear about the advancements with the Willow chip, especially in terms of error correction. Can you explain how this breakthrough in error correction will help in practical applications, such as solving complex problems in medicine or climate modeling?
The breakthrough in error correction with the Willow chip is really a game changer for practical applications, especially in fields like medicine and climate modeling. To put it simply, when you're dealing with complex problems, you need a computer that can handle a lot of data and calculations without making mistakes. In medicine, for example, scientists are trying to discover new medicines that can cure diseases. This involves simulating how molecules interact with each other, which is a very complex task. With the Willow chip, we can now perform these simulations much more accurately and efficiently. The advanced error correction means that the quantum computer can maintain the integrity of the calculations, even when dealing with a huge amount of data. This could lead to discovering new medicines much faster than we could with classical computers. In climate modeling, the situation is similar. Scientists need to simulate complex weather patterns and climate systems to predict future changes. These simulations require enormous computational power and accuracy. The Willow chip's ability to correct errors in real time allows it to handle these complex simulations more reliably, which can help us make better predictions about climate change. So in essence, the Willow chip's breakthrough in error correction brings us closer to solving some of the world's most pressing problems by providing a more reliable and powerful tool for scientists to work with. This is a significant step towards making quantum computing a practical and useful technology for real-world applications.
Let's make this relatable for our younger listeners. Can you give an example of how quantum computing might help us in our daily lives, something that a 5-year-old can understand, like faster computers for games or better weather forecasts?
Okay, so imagine you have a favorite video game that you love playing, but sometimes it takes a long time to load or to find the next level. Quantum computing can make those games load much faster and run more smoothly. This is because quantum computers can process a lot of information at the same time, kind of like how those special coins we talked about can be both heads and tails at once. Another example is weather forecasts. You know how sometimes the weather forecast says it might rain, but it doesn't? quantum computers can help make those forecasts much more accurate. By simulating all the complex weather patterns and data, quantum computers can predict the weather much better than classical computers. So if you're planning a picnic, you'll have a better idea if it's going to rain or not. In medicine, quantum computers can help scientists find new medicines faster. Imagine if your favorite cartoon character gets sick and the doctors need to find a new medicine to make them better. Quantum computers can simulate how different medicines work on the body, which helps doctors find the right one much quicker. So in simple terms, quantum computing is like having a super smart, super fast computer that can help us in many areas of our lives, from making games more fun to predicting the weather and even helping doctors find new medicines. It's really exciting to think about all the ways it can make our lives better.
That's a great way to make quantum computing relatable to everyday life. Now, let's open the floor for some questions from our listeners. We have a question from a young listener who wants to know, can you explain why error correction is so important in quantum computing, and how does Google's new Willow chip handle it?
Error correction in quantum computing is crucial because quantum computers are extremely sensitive to their environment. Imagine you're trying to have a conversation in a very noisy room. It's hard to hear each other clearly. Similarly, quantum computers can get noise from their environment, which can cause errors in their calculations. Google's new Willow chip addresses this issue through a concept called quantum error correction. Here's how it works. Instead of using individual qubits, the Willow chip uses something called logical qubits. These logical qubits are made up of multiple physical qubits working together to ensure that even if some of the individual qubits make mistakes, the overall calculation remains accurate. Think of it like having a team of people working together to deliver a message. If one person makes a mistake, the others can correct it so the message is still clear. In the same way, the logical qubits in the Willow chip can correct errors in real time, making the quantum computer much more reliable. This breakthrough is significant because it means we can now build quantum computers that are not only powerful, but also accurate and reliable. This reliability is essential for practical applications, such as simulating complex systems in medicine or climate modeling, where accuracy is paramount. So, with the Willow chip, we're one step closer to using quantum computers to solve real-world problems efficiently and accurately.
Let's move on to the interactive segment, where we can make things even more fun and engaging for our younger listeners. Here's a question from a young listener. Can you explain entanglement using a fun analogy, like a game or a story, to help us understand how two qubits can be connected in such a special way?
Okay, so let's make entanglement fun and easy to understand with a story. Imagine you have two toy cars, one red and one blue, and they are connected by a magic spring. When you do something to the red car, the blue car instantly does the same thing, even if they are on opposite sides of the room. Now, think of these toy cars as qubits. When qubits are entangled, they are connected in a similar magic way. If you change the state of one qubit, the other qubit will change its state too, no matter how far apart they are. It's as if they have a secret connection that lets them talk to each other instantly. Here's a fun game to illustrate this. Imagine you and your friend each have one of these magic toy cars. You both close your eyes, and when you open them, you see that if your car is moving forward, your friend's car is also moving forward, even if you're in different rooms. That's kind of like what happens with entangled qubits. They stay connected and can affect each other instantly, no matter the distance. This special connection is what makes quantum computers so powerful and unique, because it allows them to process complex information in a way that classical computers can't. So, entanglement is like having two magic toy cars that are always in sync, no matter where they are.
That's a fantastic way to explain entanglement using the magic toy cars analogy. Now, let's think about the future. What do you see as the next big milestones for quantum computing? And how might these advancements change the world in the next few years?
When we look at the future of quantum computing, there are several exciting milestones on the horizon that could significantly impact various aspects of our lives. One of the next big milestones will be the development of even more robust and reliable quantum computers. Google's Willow chip is a significant step in this direction, but we need to continue improving error correction and scaling up the number of qubits. This will enable us to tackle more complex problems in fields like medicine, climate modeling, and materials science. For instance, in medicine, quantum computers could help us discover new drugs much faster by simulating the behavior of molecules at a level that classical computers can't. Imagine being able to find a cure for a disease that currently takes years or even decades to develop. Quantum computing could make that process much quicker. In climate modeling, more accurate and powerful quantum computers will help scientists predict weather patterns and climate changes with greater precision. This could lead to better planning and mitigation strategies for natural disasters and environmental changes. Another area where we'll see significant advancements is in cryptography. Quantum computers can break some of the current encryption methods, but they can also help us develop new quantum-resistant encryption techniques. This will ensure that our online transactions and communications remain secure in the quantum age. Overall, the next few years will be pivotal for quantum computing as we move from academic breakthroughs to practical applications. These advancements have the potential to transform various industries and improve our daily lives in ways we're just beginning to imagine.
That's a fascinating look into the future of quantum computing. To summarize and make it even more relatable for our younger listeners, can you give a simple example of how discovering new medicines faster through quantum computing could impact a child's life, perhaps in a way that's easy to visualize?
Okay, so imagine your favorite stuffed animal or toy gets very sick, and the doctors need to find a new medicine to make it better. Usually, finding the right medicine takes a long time because scientists have to try many different combinations to see what works. With quantum computing, it's like having a super fast and super smart helper that can try all those combinations at the same time. This helper, the quantum computer, can simulate how different medicines interact with the body much faster than any classical computer. For example, if your stuffed animal has a specific illness, the quantum computer can quickly test millions of different medicine combinations to find the one that works best. This means that instead of waiting years or even decades for a new medicine, scientists can find it much, much faster. So, if your stuffed animal gets better quickly because of a new medicine discovered by a quantum computer, that's a direct way quantum computing can impact a child's life. It's about making the process of finding new medicines faster and more efficient, which can help make everyone healthier and happier. This is just one of the many ways quantum computing can make a real difference in our lives.
That's a compelling look at the future of quantum computing. To make it even more tangible for our younger listeners, can you describe how quantum computers might help in something as everyday as predicting the weather, and how that could affect a child's plans for a picnic or a trip to the park?
Okay, so let's talk about how quantum computers can help with something as everyday as predicting the weather. Imagine you're planning a picnic or a trip to the park, and you really want to know if it's going to rain or be sunny. Classical computers can try to predict the weather by using lots of data and complex calculations, but they have limitations. They can only process so much information at a time, which means their predictions might not be as accurate as we would like. Quantum computers, on the other hand, can handle a huge amount of data all at once, thanks to those special qubits we talked about. They can simulate all the complex weather patterns and interactions in the atmosphere much more accurately and quickly than classical computers. For example, if you're planning a picnic, a quantum computer can predict whether it will rain or not by simulating all the possible weather conditions. This means you'll get a much more accurate forecast, so you can decide whether to bring an umbrella or not. In simple terms, quantum computers can make weather forecasts more reliable, which can help you plan your day better. Whether it's a picnic, a trip to the park, or just knowing what to wear, having more accurate weather predictions can make a big difference in your daily life. So, with the help of quantum computing, you'll be better prepared for your outdoor adventures. And that's just one of the many ways quantum computing can make our lives easier and more predictable.
That's a great example of how quantum computing can improve weather forecasts. Now, let's think about another everyday application. How might quantum computers help in making video games more exciting and responsive, especially for our young gamers listening in?
Okay, so let's talk about how quantum computers can make video games more exciting and responsive. Imagine you're playing your favorite video game and it takes a long time to load the next level, or the game freezes because it's processing a lot of information. Quantum computers can help solve these problems. Quantum computers can process a huge amount of data much faster than classical computers. This means that in a video game, quantum computers can handle complex graphics, simulate realistic environments, and even predict the actions of characters in the game more accurately and quickly. For example, if you're playing a game where you need to explore a vast virtual world, a quantum computer can generate this world in real time, making the game feel more immersive and responsive. It can also help the game's AI make smarter decisions, so the characters in the game behave more realistically. Additionally, quantum computers can optimize the game's performance, reducing lag and making the gameplay smoother. This is because they can solve optimization problems much faster, which is crucial for games that require quick and efficient processing. So, in simple terms, quantum computers can make video games load faster, run smoother, and feel more realistic. This can make your gaming experience much more enjoyable and engaging, which is really exciting for all the young gamers out there. It's like having a super-powered computer that can handle all the complex tasks in your game, making it more fun and interactive.
That's a great example of how quantum computing can enhance video games. Now let's think about the broader impact. How do you see quantum computing changing the way we approach problems in various fields, such as medicine, climate modeling, and materials science in the next few years?
Quantum computing is poised to revolutionize how we approach problems in various fields, and it's exciting to think about the impact it can have in the next few years. In medicine, for instance, quantum computers can simulate the behavior of molecules at a level that classical computers can't. This means scientists can design new medicines much faster and more accurately. Imagine being able to find a cure for a disease that currently takes years or decades to develop. Quantum computing could make that process much quicker. Personalized medicine is another area where quantum computers will shine, allowing for treatments tailored to individual genetic profiles. In climate modeling, quantum computers will help scientists predict weather patterns and climate changes with greater precision. This will enable better planning and mitigation strategies for natural disasters and environmental changes. For example, quantum computers can simulate complex weather systems and predict the effects of climate change on specific regions, helping us prepare and adapt more effectively. In materials science, quantum computers can simulate the properties of materials at the molecular level, leading to breakthroughs in battery technology, new types of superconductors, and more efficient energy storage and transport. This could revolutionize how we power our homes, cars, and devices, making our world more sustainable and efficient. Overall, quantum computing is not just about solving complex problems faster, it's about opening up new possibilities that were previously beyond our reach. It's an exciting time as we move from theoretical breakthroughs to practical, real-world applications that can transform various industries and improve our daily lives.
Thank you for tuning in to Chatbotcast. We hope you enjoyed this episode and found it engaging. Don't forget to subscribe so you never miss an update, and visit us at www.chatbotcasts.com to explore more exciting episodes. See you next time, and happy listening.